Hello again. Here we continue our factoring lesson. In this video, we learn how to factor by grouping. And this skill will help us when we talk about factoring trinomials, which is where we will end up. We start with an example like this. X multiplied by x plus 2 minus 3 multiplied by x plus 2. Now, there are two terms in this expression. X times x plus 2, that's one term. And 3 times x plus 2, that's another term. And you are subtracting them, is what you're doing. Now, what we want to do here is to see if we can identify the greatest common factor of these two terms. Well, I hope you can see, or you can observe that there is a common factor here. X plus 2 is common to those two terms. There is nothing else common to those two terms as far as factors are concerned. Therefore, the greatest common factor of those two terms is x plus 2. Like we did in our previous video, once you identify the greatest common factor, you have to factor that greatest common factor. You write that outside of a bracket, and then inside the bracket, so we have now written our factor, our greatest common factor, x plus 2. We have written that now, but because that has more than one term in it, that's why I've put it in a bracket, okay? I'm now going to open another bracket and divide the terms inside the bracket by our greatest common factor. So what I am going to do now is divide x times x plus 2, divide that by x plus 2. If you divide x times x plus 2 by x plus 2, the x plus 2 will just cancel out and you just have x left in there. Similarly, if you divide 3 times x plus 2 by x plus 2, you just have 3 left because the x plus 2 will cancel out. Therefore, this expression we started with, x times x plus 2 minus 3 times x plus 2, in factored form is x times x plus 2 multiplied by x minus 3. So that's what we're going to do here. And we're going to take examples that lead us to doing factoring by grouping in this way. So let's start with this. 3x plus 9 plus bx plus 3b. What we are going to do here is, because we have 4 terms in here, we are going to group the terms. We're going to group them in pairs like that. We're going to group the first 2 terms and the last 2 terms and find the greatest common factor of the first 2 terms, find the greatest common factor of the last 2 terms, and then factor those out as follows. The greatest common factor of 3x and 9 is 3, and the greatest common factor of bx plus 3b, or bx and 3b, is b. If you follow the process we talked about previously, that's what you're going to discover. And then we factor out the 3 from the first 2 terms. If you factor 3 from 3x plus 9, you would have 3, which is the greatest common factor of 3x and 9. And if you divide each term by this greatest common factor, you would have x plus 3 inside the bracket. Similarly, we can factor out the greatest common factor of bx and 3b. The greatest common factor is b. And if you divide each term in the expression by the greatest common factor, you will obtain x plus 3 inside the bracket. You can see that what we have just obtained looks like what we had in the previous slide, where we had these 2 terms, but one of them is in bracket. The common factors are in bracket. Similarly here, you can see that x plus 3 is a common factor. In fact, that is the greatest common factor here. We can now factor the greatest common factor out from there and open a bracket, and the result we are going to have in the bracket, or the terms in the bracket, will be the original terms, 3 times x plus 3, divided by the greatest common factor we found, x plus 3. Our result will be 3. And if we do the same thing with the second term, b times x plus 3, we divide that by the greatest common factor, x plus 3. Our result will be b. Therefore, our original expression that we started with in factored form is x plus 3 times 3 plus b. Now, like we did in our first lesson, if we want to know that our factoring is correct, all we have to do is redistribute, remultiply right? Expand the brackets. Those are all synonymous statements. And if you do that like you learned to do in your previous math course in Math 10, you would see that the expansion, right, will be as shown. If you multiply x times 3, you get 3x. If you multiply 3 by 3, you get 9. If you multiply b by x, you get bx. If you multiply 3 by b, you get 3b, which is the original thing we started with. So our factoring is correct. Let's look at another example here. 2xy plus 2y plus 3x plus 3. We do the same thing that we did previously. We pair up the terms, we group them together, and find the greatest common factor of the paired terms, and then we will write the greatest common factor outside of the bracket and divide each term by the greatest common factor we just found for each of the two paired terms. And therefore, in this case, when we do that, this is what we're going to obtain. 2y times x plus 1 plus 3 times x plus 1. You can see that we just come to where we started earlier, where we have common factors x plus 1 and x plus 1. That is now the greatest common factor in these two terms. We can factor that out and divide each term by the greatest common factor. Our result will be 2y plus 3. Similarly, if we want to know that we're correct, we simply redistribute into the bracket, and we'll see that we obtain the original thing we started with. Sometimes you have a scenario where you have to regroup the terms even after you've done the factoring. So if you factor and the terms in your brackets do not match, you may need to regroup. So for example, if we just pair these terms and we find the greatest common factor of the two terms, of the paired terms, you will see that the greatest common factor will be 2 and x. And if we factor 2 from the first two terms and x from the second two terms, this is what we're going to obtain. You can see that those expressions in the brackets, they are not the same, right? So that's not a common factor. So we can't factor the way we've done previously. So what we have to do is to take our original expression and rearrange the terms. So instead of having the terms the way they were before, we can rewrite as 10x squared plus 15x minus 12y minus 8y. And now, if we rewrite this, we can then we can then pair the terms and factor the way we had done previously. Right. So if we do that now, the expression we will obtain for our greatest common factor will be 5x, and for the first two terms, and for the second two terms, the greatest common factor will be 4y, which if we factor out from the expression by dividing the terms by the greatest common factor we just found, we will obtain 2x plus 3 in the first bracket and 3 plus 2x in the second bracket. But 2x plus 3 and 3 plus 2x are the same things, right? The order in which you add things don't matter. 2 plus 3 and 3 plus 2 are the same things. So 2x plus 3 and 3 plus 2x are the same things. So now the greatest common factor is 2x plus 3, and we can factor the greatest common factor from there, and we'll obtain what we had as shown previously, 2x plus 3 multiplied by 5x minus 4. So the original expression we started with in factored form is what we have now, and if we expand that, you will see that you'll get the original thing back. Now what I'm going to show you now is a kind of reversal process where we learn to factor trinomials. So let's start with x plus 2 multiplied by x plus 3. So let's distribute that and see what we get. If we distribute into the bracket, here's what you're going to obtain. You have x squared plus 3x plus 2x plus 6. 3x plus 2x, those are like terms. From your study previously, you know that you can combine those together, and your result will be x squared plus 5x plus 6. This is a trinomial. It's a polynomial with 3 terms. Now, is there a way we can rewrite this? Okay, well, how can we rewrite this? What process should we follow, or can we follow, so that we write this in factored form like we've done previously? I'm going to show you how to do that. To do that, what we're going to do is to take this trinomial that has 3 terms in it and figure out 2 numbers. We need 2 numbers here. The first number, the 2 numbers must be such that they add up to the coefficient of x. So when you add these 2 numbers we're going to find together, you will get 5, or you must get 5. And when you multiply these 2 numbers together, your result will be 6. Now, why is this 6? Take the coefficient of x squared, which is 1, and take the constant term, which is 6. 1 times 6 is 6. So the number we're going to look for must multiply to 6 and must add up to 5. Let's see what numbers will do this. 1 and 4 add up to 5, but 4 times 1 is not 6, so that's not going to work. 0 and 5 add up to 5, but 0 times 5 is not 6, so that's not going to work either. But what about 2 and 3? 2 plus 3 is 5, and 2 times 3 is 6. Therefore, this is our candidate. This is what we want. We want the numbers we're looking for are 2 and 3. What do we do with these two numbers? What we do is we rewrite the middle term, 5x, as a sum of these two numbers, 2x plus 3x. So x squared plus 5x plus 6 becomes x squared plus 2x plus 3x plus 6. 2x plus 3x is 5x. And now we can regroup like we did previously. We can regroup two terms in pair. We can regroup them in pairs and factor out the greatest common factor. From the first two terms, the greatest common factor is x. From the last two terms, the greatest common factor is 3. And then you will have expressions in bracket x plus 2 and x plus 2, which will be the result after dividing by the greatest common factor. And you can factor x plus 2 again. And your result will be x plus 3 inside the bracket, which gives us back what we started with. So now, let's do another one. X squared plus 10x plus 24. We want to factor this trinomial in the same way that we just did. We are looking for two numbers that add up to 10, which is the middle term, coefficient of the middle term. And when you multiply the leading coefficient, the coefficient of x squared, which is 1, you multiply that by the constant term, which is 24. Your result is 24. So your numbers must add up to 10 and multiply to 24. 9 and 1 add up to 10, but 9 times 1 is not 24, so that's not going to work. 8 plus 2 is 10, but 8 times 2 is not 24, so that's not going to work either. 7 times 3 is 21, but 7 plus 3 is 10, but 7 times 3 is not 24, so that's not going to work either. But 6 plus 4 is 10, and 6 times 4 is 24, so that's what we're looking for. This will work just fine. So therefore, we will write the middle term as a sum of 6x and 4x. Therefore, x squared plus 10x plus 24 will be written as x squared plus 6x plus 4x plus 24. And now we can simply do what we did previously, regroup the terms and factor out the greatest common factor, and our result will be as shown. So, why don't you try now and factor and regroup the examples here. And like we said previously, please pause the video after you can see the questions and try your hands on the examples. And after you're done, you can restart the video to see what I have done. So pause the video now. So what did you do? So here's what I have done here. As you can see the first example there, what you have to do there is just to group the four terms in pairs and find the greatest common factor of each pair of terms, and then that will be 3x for the first two terms and 1 for the second two terms. And if you factor that out, your result will be as shown. And for the second example here, you can see that your first two terms and your second two terms, you factor them out, your result, you don't have matching factors. So you have to rearrange. If you rearrange the expression and pair them up like we did previously, like I've shown you, your result for the first two terms, the factors will be 2z, and for the second two terms, it will be 3w. And if you factor those out, you can see that in the brackets, you have z minus 2 and 2 minus z. Now, those are very close. It is like having 2 minus 3 and 3 minus 2. The difference is always a minus 1. So instead of factoring out a 3, w for the second two terms, factor out a negative 3w from there. Now that will change the terms for you, and it will become just like the other one. And then you can factor out the z minus 2, and your result will be as shown. And finally, to factor the trinomials, we are looking for two numbers whose sum is 4 and whose product is negative 5. In this case, the result will be 5 and negative 1, and you can rearrange as we have shown before, and your result will be a plus 5 and a minus 1. And for the last example here, you do the same thing. You are looking for two numbers whose sum is 7 and whose product is 12. That is 4 and 3 in this case. And if you rearrange and you factor, your result will be as shown. 2p plus 3 and p plus 2. So p plus 2 times 2p plus 3. So this concludes our video for factoring.